Hi everyone. This week we move on to our Tide practical and we'll be looking at a site in China. So again, make sure you navigate to your folder where you have code and data. Again, in MATLAB, make sure that you're always working from that folder. So this is my folder here. You should be in code. Always separate out things. I've noticed in the practical some people are mixing up their folders, so try and keep your folders quite simple. Now what we're going to do is we're going to go in and, as always, download our template. And actually this time we're going to download 2 files, and I'll explain that to you later. Okay, so go to downloads, copy those 2 and pop those into code. And then what I want you to do is load in the practical tides template. Okay, and we have that here. So in this MATLAB live script, we're going to be using netcdf data, which is very similar to, well, it's the same format as what we used for the weather one in the Sandy practical. Now notice this week I've got this word function at the top. That's very important because we'll come back to that at the end. Okay, so as always, clear all the variables. That's the clear function, comma, and then CLC clears the screen. And again, we set up a site identity. This time it's going to be 376. This is going to be our site in China. We can run that code, see that our variable there is generated. Now we're going to go to the University of Hawaii Sea Level Center. Now when I tested this early in the week, it wasn't working, the site was down, but I have emailed them, so hopefully the site is up and running now. Okay, so what we want to do is go to, it's being a bit slow, but we'll go to data. There is different ways to download the data, but I'm actually going to go to this Open DAP server. You can have a play around with some of the other one. Now they have fast data, which is not quality controls, but we're going to go for this research quality data set. We want to go for the Pacific Ocean, and we want to go have hourly data, and then we're going to scroll down to just check, but 376. So is it 376 or 376? So we're going to scroll down to 376A, this file here. I'm going to click on that. And now they have changed this, but what we can do is go to the netcdf3 and we can get data. Now what is actually nice is you can actually load this in automatically into MATLAB, but for the time being we're just going to download the file. Now I have had some problems with this file hanging. I'm not too sure why that is. For some reason it hasn't downloaded. I'm just going to wait for that. In the meantime, while I'm waiting, I'm just going to download the file from here just as a sort of backup, so I don't have to wait for too long. Okay, and I'm going to copy that over into the data folder. Now because I was downloading it, it's changed the name, so I'm just going to delete that, and we've got that file there. Okay, yeah, I have had problems recently with this downloading. I'm not too sure why. I'll email the University of Hawaii Sea Level site again. Okay, so now we're going to load in the data, and again we're going to create a file name. Again we're going to try and not copy this. Now if you're in code, you want to go, so we're in code folder, we want to go back into the practicals folder, then up into data, and here is our file name. But again, we don't want to hard code this, so we are going to use double quotes, and then we are going to add this to the number, but we've converted the number into SID, but we need to change it from a number to a string. Okay, so that should be our file name there. Okay, very good. Now what we're going to do is, like we did before, we're going to use the NCDisplay function on that file in, and this is going to tell us how that file is formatted. Just going to go back. It's still hanging for some reason. It was working when I checked it early in the day, so I don't know what's going on now. Okay, so here we can scroll down and you can see there's a lat long, a station name, station country, various things that we could want there, a time, but the key one is sea level. Here you can see, because it's hourly data set, it's quite big. There's 385,696 values for this one. Okay, and then what we're going to do is we're going to scroll down here, and first of all we're going to read the station name. So it's N. It's going to, remember we use the NC read function. So first of all you specify the file, then you specify the variable you want. In this case it's station understroke name. Station understroke name. So we're going to run that, and you can see for some reason it gives the name as a column, but we're going to do the transpose to convert it into a row. So there we have our station name, which is quite useful because we can use that for plotting. Okay, now we're going to load in the time. So this is going to be nc read file in time function. Now if you go back up to time here, you can see that the time is in days since 1800, but in MATLAB time is relative to kind of BC, so we need to add on 1800, day 1, month 1, hour 0, hour minute 0 seconds. Okay, and then we can run that, and that's going to load in our timestamp. So the data you can see here starts in 1954, and it goes all the way through to 1997. So actually we don't have recent data for this site, it's an old one. We're then going to load in the sea level. I'm going to say WL. Again, it's NC read, the file in, and then the variable name. Here it's C understroke level. Now, again, if you go back into sea level, check what the units are. But here the units are in millimeters. So what I'm going to do is, you could do this in two separate things, but I'm just going to divide by 1,000 to get into meters. And then finally, I'm going to download in. When you do a tidal analysis, you need the latitude. So I'm going to load in the lat, and I'm going to load in the long. And again, if you wanted to, you could plot the site location and check that. Okay, so there's our latitude and longitude. Okay, now we can plot the data. And as always, I'm going to go back into a previous practical. Rather than me having to type this from scratch, I'm going to go back here and just nick code. Always nick code. Okay, now here we want a what do we want? 3 rows. Now what we're going to do is, I'm going to do 3 rows. Okay, and again I'm going to nick some code here. Again, you might as well nick everything because you can delete what you don't need. But now what I'm going to do is going to plot the time against the water level. Let's plot it in blue. Okay, now what I want is the title is going to be the name. So I'm going to do num2 string sid plus the name. I'm going to do comma space and then plus the name. Okay, I'm going to have date level and meters. Going to make that blue. Grid on X. I don't need anything else. So let's just run that and bring up our first tide. Okay, so here's the tide for the whole period. You can see there's some missing data there. You can see I've put the name. Now by being flexible here, if I go back and update this SID to a new site, download some new data, you should be able to see that that will automatically update. Okay, what I'm going to do now is do the next tile, but this time I'm going to plot the data just for July. Just for 1996. Okay, so I can keep everything exactly the same, but here I'm going to put a xlim. I always try and put things in the same order. Because you need to put a brace in there, but what we can do is we can say date time, Now here I'm just going to do 1996. So put in the days, months, years, hours, minutes, seconds, and then I'm going to put that to 1997. Okay, I'm going to take the title out here because I only want the title on the first one, just the site. And then here I'm going to do July. So I can put that as 7 and then this as month 8. And again, I'm going to set all axes as bold just because when I save that, it looks much nicer. Okay, so there you can see you have the data, you have the months, you have the years, and then here on the final one, sorry, I need to change that to 1996. So yeah, here you can see that every month you have 2 spring leap tidal cycles. As you learned in the lecture, one is bigger than the other because the moon goes around in an elliptical path. So you have perigee when it's close, apogee when it's fast. You have your highest tides around the equinoxes. So here you can see we have 2 tides a day. Again, we can see the spring leap tidal cycle there. This is probably some sort of tropical cyclone event